Hi everyone, welcome to our 10th Node.js Meetup. For those who don't know me yet, my name is Marta and I work for DataArt company. And I'm super happy that a few of you decided to join us this evening, especially that we have such a beautiful summer outside. I promise you, you will not get bored today. We have a fantastic speaker, Bartek Iwańczuk, and our great host, Cezary Dynak, who will tell you in a minute what is our agenda for today. Just to finish my talking, I would like to say thank you to STX Next company for support and for co-hosting this event today. And it is a pleasure, guys, to cooperate with such a great team, and I hope it is not the last time. Okay, enough of my talking from my side. Cezary, Zbyszek, now it's your turn.
Yes, hello. So thank you very much, Marta. So yeah, thank you very much also the awesome DataArt team in the background. So really you help a lot to make possible this meetup event to grow. And today we really have an amazing guest, Bartek Iwańczuk from Deno company. So possibly you know something about Node.js, but how much do you know about Deno? Yeah, and I believe this talk will be very useful for you. Possibly you can also watch it once again, and really please ask questions. Don't hesitate to write even it right now. If you're online, please write your cities, write your ideas, whatever. Be active here. Hello, everyone there, and also the organization of this meetup is very experimental. So one of the things is that at the end we have a musical surprise. There will be a Francis Tuan playing on guitar and his instrument at the end after the Q&A. But also on the beginning we have Zbyszek Tenerowicz, who is one of the key figures in Mid.js Meetup series. And here's the idea of merging the Wrocław Node.js meetups and Mid.js Wrocław meetups to create something like a Mid.js backend. That's the idea for now. But Zbyszek can tell about you more about how we met here and what are his expectations and ideas about the series.
Okay, so you spoiled my point here. So thanks. But yeah, what's happening is there was a Node.js meetup in Wrocław, and there was also a few attempts, initiatives to run something that's more Node specific or more non-browser JavaScript specific in Meet.js. So some folks from Katowice were trying something. I started node.meetjs.pl, which also links to Meet.js Wrocław. And now we have a chance to attempt doing some Meet.js backend stuff together. So this is very experimental, as everyone said already. But this is probably first of a series of meetups that are going to be a cooperation. And Meet.js is open to like merging or helping organize or just running together with a backend meetup as well. We always wanted to do that. The pandemic kind of interrupted it a little, but this is a good fresh start. And let's hope we iron out the differences in branding and get under one same brand so that we can all organize for the same community. Because there's only one community and Meet.js wants to do everything for the community, not any other interest in particular. So I hope this is gonna last, because that's my goal, to make meetups last under our branding. It tends to be a bit easier with the motivation.
Exactly. Thank you very much, Zbyszek, for a lot of inspirations about what we can do. It's all about JavaScript, and also it's about so Deno is also about JavaScript. It's moving the JavaScript engine to the backend. Yeah, so JavaScript is the core here. So that's why Meet.js is a perfect fit. This is Meet.js backend number 0, so we'll have definitely number 1 and the next editions. But let's go to the core, and warm welcome for Bartek Iwańczuk, who will tell about the Deno internals.
Thank you. First of all, huge thanks to you for having me here today. I prepared a talk where I'll discuss some of the more low-level stuff in Deno, especially how Deno is built and why it's not a monolithic project. I must warn you, this talk will involve quite a bit of Rust, but don't be scared. I'll try to explain everything in depth, and if anything is not clear, please don't hesitate to ask questions during the talk. I'll try to answer them as soon as possible. So just a couple sentences about me. I'm Bartek. I'm developer in Denoland company. I've been contributing to Deno since 2018, and I've joined the team in late 2019. And since then, we've been developing Deno as an open source project. And now we are pursuing other endeavors which build on top of this open source project. So the goal of this talk is to explain to you why Deno is not a monolith project, but rather a collection of smaller projects. I want to highlight some of the most important parts of the runtime, which are responsible for different actions that's happening there. And I also want to dive a little bit deeper into how Deno communicates between JavaScript and Rust. So let's get right to it. Deno is a command line runtime for JavaScript and TypeScript that's written in Rust. It means that it's a project similar to Node.js that allows you to execute your JavaScript code on the server. However, this is a completely new project that started in 2018. It was first introduced to the world on May 13th, 2018 by Ryan Dole in his famous 10 things I regret about Node.js presentation. We released the version 1.0 last year on May 13th, and this is not a coincidence. We actually did it on purpose exactly 2 years after the first introduction. And since 1.0 release, we haven't really stopped, and we are currently at version 1.11.1. We release Deno monthly, so every month you get a new minor version, and we try to release new patch versions every week or every 2 weeks. Some of the features that Deno is famous for or recognizable for is that, first of all, it's secure by default. It does not allow you to access file system, internet, environmental variables, or even spawn a sub-process unless you provide appropriate CLI flags. Deno does not use CommonJS and require syntax for importing modules. Instead, it uses URLs, just like in browsers. So Deno implements ES module specification. Deno also supports TypeScript out of the box, which is one of the biggest selling points. That is, Deno does not execute your TypeScript. It actually transpiles your TypeScript to JavaScript first, but all of this is happening behind the scenes, so you don't have to set up your build chain. It's all taken care of for you. All APIs in Deno are promise-based, so there are no callbacks. Every API that is asynchronous returns a promise. And also Deno ships with a standard library, which is written in TypeScript, and I'll link to it at the end of the talk. And one of the biggest features is that Deno tries to use web standard APIs wherever appropriate. That means if there exists already an API that is used in browsers and it makes sense to use it on the server side, Deno uses these APIs, implements them instead of inventing proprietary APIs. So some of the examples are fetch or maybe WebSockets. We also have a support for WebGPU, events, blobs, text encoder and decoder, and some of the more archaic APIs like prompt confirm and alert, which allow you to write CLI programs in just a few lines. Excuse me. So Deno is a runtime, but not only that, Deno actually includes a whole tool chain of stuff that you might find convenient when developing JavaScript or TypeScript programs. So not only can you run your program, but also you can, for example, bundle it, or maybe you want to format your code, or even generate a documentation on the fly out of your JS docs in the public APIs. Or maybe you want to distribute your program, so then you can use Deno install to install your script on some other machine. Or even a step further, maybe you want to compile your program to a single executable, which means that we'll actually package the whole Deno binary alongside with your code into a single executable file that you can then zip and ship to your friends or coworkers who won't need to install anything for their machines. They can just run the binary you provided. So as such, because we have such a big tool chain, Deno is not a single big project. Instead, it consists of many subsystems responsible for different subcommands, which leads us to the first point of my talk, in that Deno is not a monolithic project. Instead, since it's written in Rust, it's a collection of Rust crates. And you can take those Rust crates, reuse them, and mix them together in different ways to create custom runtimes for your needs. So, for example, you might not need access to the internet, or you're not interested in file system access. And with Deno infrastructure, it's possible to compile out those binaries, those bindings, which will decrease your binary size and allow you to create a bespoke runtime exactly that fits your needs. I've linked my previous talk on this subject from last year here, which goes into details for higher level stuff like TypeScript compilation or dependency analysis. But in this talk, we'll be focusing on the actual execution of code. So why is this collection of crates useful? Why this approach is useful? As I said at the beginning of my talk, Deno company not only provides the Deno binary that you might download, we also work on a commercial project called Deploy, and Deploy is a globally distributed JavaScript virtual machine. That means that we're able to execute your JavaScript code on the edge, close to your users, and over 20 locations all over the world. And the great thing is that this is not a separate project. We don't have to write everything from scratch. Instead, Deploy is built on the exactly same infrastructure as the Deno binary. So coming back to the example from a few minutes ago, Deploy runs on the edge and thus has no file system because all the storage is ephemeral. So we just compile away those bindings and provide you with only the APIs that are actually useful in that context. So there are a few main parts of the runtime. In the talk that I linked a few slides back, I'll walk through all of them, but today we will only focus on the ones that are in bold. So the actual JavaScript engine, the V8 in case of Deno, and the so-called extensions. So those are Those are Rust crates, or think about them as just packages like npm packages that provide you with common functionality that could be used in different runtimes. One of the examples would be Deno console, which implements the console API known from browsers. So let's start with the biggest part, the most important one that is actually responsible for executing your code. And this is the V8 JavaScript engine. V8 is the most sophisticated and fastest JavaScript engine that exists. It's used in Google Chrome and Chromium and other related Chromium projects. I believe that would be Microsoft Edge browser as well. Deno is very tightly integrated with V8. So that means you cannot just switch the underlying engine. We cannot swap out V8 for SpiderMonkey or QuickJS just because we use a lot of API surface provided by V8 that is specific to V8. So one of the hard parts of V8 is that it's a C++ project, and it's massive. It's way over 500,000 lines, takes more than 30 minutes to compile, and is in general very, very complicated and has a huge API surface. So you might be asking yourself, V8 is written in C++. I just told you that Deno is written in Rust. So how do you reconcile the two? Well, we have an FFI layer, that is foreign function interface layer. So we have a special mechanism that allows you to talk between Rust and C++. And historically, this was first done using something called libdeno, which was a C++ library, rather small library. It had about 30 functions that allowed us to integrate with V8 and Rust, and was a great stepping stone to get Deno off the ground. However, libdeno was really mostly exchanging pointers back and forth. So reasoning about this library was pretty hard, and adding new functionality was even harder. So it was great to get us off the ground, but we quickly hit the wall with what we can do using libdeno. And thus, in late 2019, Rusty V8 was born. Rusty V8 is a Rust crate written by Deno company that provides you with safe and zero-cost bindings to V8. That means you don't have to compile V8 engine yourself. We provide you with a nicely packaged Rust API that is as close to the C++ API as possible without any overhead. And one of the most important features, actually there are two very important features. First one is that you manipulate the same objects in Rust as you do in C++. So it's not some kind of proxy, it's actually manipulation of the same underlying memory. And secondly, we abstracted away the whole build step of V8. As I just mentioned, V8 is a huge project and takes over 30 minutes to compile. So instead of doing that, we provide you with pre-built binary file with all of the V8 built in. So you can just download it from our repository and use it instead of going through the hoops to compile V8 yourself.
Bartek, wasn't there in the beginning an attempt to use Go instead of Rust?
Yeah, so the first ever version of Deno was actually written in Go, but it was quickly abandoned in favor of Rust for one simple reason. Go is a garbage collected language, and JavaScript is a garbage collected language as well. So there were questions about not if, but when the two garbage collectors will start to contest against each other. And thus, the decision was made to rewrite the whole system in Rust.
Makes sense.
Okay, so now we know what actually executes code in Deno, the V8 engine, but what comes next? So because of the huge and complicated API of V8, we provided another low-level layer of integration that abstracts away all the nitty-gritty details of V8, instead providing a concise API in Rust. This project is called Deno Core, and this is a basis for all integrations in the Deno ecosystem. So you don't have to do through all the setup steps yourself if you want to run JS engine. Instead, we provide you with a nice abstraction that is called JS runtime. It's a Rust structure that encapsulates so-called V8 isolate. And the isolate is, you can think of it as an isolated instance of a JS engine. So if you create two of them, they cannot talk to each other. They do not share memory, and well, they are isolated. And this JS runtime actually provides the most important building blocks for modern runtime. So for example, ES modules is quite a new specification on how to provide a module system in JavaScript. And it's very complex, especially since addition of so-called top-level await. So that means that you can use await keyword in any place in your code. It doesn't have to be inside the async function. You can use await at top level too. So introduction of this top level await complicated the whole setup a bit, but long story short, loading and execution of ES modules is completely asynchronous. So you might be actually fetching multiple source files concurrently at the same time, and only after you've got your whole graph of the modules, you can execute them. And this is very non-trivial task. The spec that tells you how to do that is a lot of pages with a lot of hard words. So we just took care of it and abstracted away the whole loading into 2 or 3 functions that well, are configurable because of the loaders that you can pass. So for example, you might only need to load your files from file system, then you can use already built-in loader, but you might also want to provide downloading modules from remote servers, just like Deno CLI does. So then you can create another loader that takes care of stuff like caching remote files, or you might even want to load modules from in-memory or parse some files on the fly. You can do all of that in Deno using this configurable loader, and don't need to worry about order of execution. Another very complicated part of the system that is already integrated in Deno Core and exposed as a Rust API is so-called V8 inspector. So I'm pretty sure that most of you have used Chrome DevTools at least once in your life. And V8 inspector is the thing that talks to the DevTools. So when you create a new isolate, you can also create an inspector alongside it, and then exchange messages with this inspector to be able to introspect your code, or place a debugging breakpoint, or do profiling, or maybe even inspecting your heap, your JavaScript heap. And again, integration with this inspector is very non-trivial, but Deno Core provides it out of the box, so you don't have to worry about it. Word of caution here, Deno Core has no notion of TypeScript. It's completely agnostic of TypeScript. It can execute only JavaScript and WebAssembly, because V8 supports executing JavaScript and WebAssembly. And if you want TypeScript support, this is built on higher layers of the whole stack. And in the talk I linked you a few slides ago, this is explained in more depth how it's done in Deno. So to give you an example how easy it is, here's a snippet that uses Deno core to execute some code. So this is Rust. We have an async function that we named run.js code, and it accepts a single parameter that is source code for the stuff you want to execute. So it's as simple as creating a new instance of the JS runtime. We can, for now, skip this part, which is default. It just tells that we don't want to customize our runtime in any way. And then you just execute your code using execute function. The last line is run event loop. So this is the actual integration with event loop that allows you to run asynchronous code inside your V8 virtual machine. So if you use promises or maybe you got some event listeners, all of those are handled by the event loop. For each tick of event loop, some promises might be resolved or rejected. And that's how you make progress in your asynchronous JavaScript code. Okay, so yeah, I talked about how we execute the code, that we have some nice abstractions that make it easier, but what about the APIs like fetch or WebSocket? Those APIs are not pure JavaScript. They interact with the NetSockets. If you use fetch, you want to download some data from a remote server, or if you use WebSockets, you want to have bidirectional communication over NetSocket. Like JavaScript cannot open a NetSocket. How do you do that? And to do that, we need to reach out of this JavaScript engine and go into the Rust code to perform those operations. So here's a simple diagram. It's a huge simplification of what's actually going on in the Deno process, but for the sake of this talk, you can imagine that Deno process basically consists of some Rust code that does several things. And somewhere inside that Rust code, there is a V8 engine that actually executes your JavaScript code. And one of the most important APIs provided in Deno core are so-called ops. Ops are, well, it's a way how to call Rust code from within JavaScript code. So to give you an example, here's a totally fake call that uses JavaScript API, and it's called opsing, which takes a name of your function that you want to execute, and you can give it 2 arguments. And those arguments can be anything, a list, an object, maybe a map or a set, whatever you want. And once you call this API, then we will break out of this JavaScript engine over here and go and call appropriate function in Rust that matches the name that you provided. Once that function is executed, we go back to JavaScript and resume execution as it was. So I've actually got a small hello world example from our repo just to show you the actual code, because it might sound very complex, but in essence, it's not that hard. So once again.
Also, don't afraid. I mean, to everybody who is on watching for us on Facebook, on YouTube, ask your questions right now, even if you have them. I will forward them to Bartek.
Okay, so let's go through this example real quick. Once again, we create a JS runtime, a new instance that just uses the default settings. And then we call a function called register op. And this is where the magic happens. You register a function under some given name. In this case, this is opsum. Then you use a special wrapper provided by Deno called opsync. This tells the JavaScript engine that you can call this function, and it's a synchronous function. We also have opasync, which allows you to call some asynchronous function and then resolve a promise with a result. So in here, we actually use only a single argument called nums, which is a vector of 64-bit floats. And well, we iterate over this vector and then add all of the elements together. And then we return the result as, well, as a result. This is a special Rust type that is either okay or it's an error. So in our case, we can either return a 64-bit float or just any error. This part is not that important, but just for your sake, it like tells both sides, both JavaScript and Rust, hey, I've got some new functions that now you can call me under a given name. So please synchronize both sides for me. And in here, we got actual JavaScript code. So once again, we use the execute method to actually run our JavaScript code. And let me walk you through it. So we've got a simple helper here that will display a line of text to the standard output. This is a completely internal function that is used for debugging. As you can see, you need to append a new line yourself. So this is not a console. We will get to the console a bit later. And in here, we create an array with 3 elements. Then we print some stuff. And then we actually call our op, the op sum. So we're telling Deno, we're in JavaScript now, and we're telling Deno, hey, go to the Rust side and call this function with name opsum for me with provided argument. So in our case, this is this array of numbers, and then in Rust, it will be translated into vector of 64-bit floats. I will describe in detail how this translation happens in the coming slides. But let's try to actually do a live demo. So let me switch to my terminal. By the way, you can run this code yourself. So I need to switch once again. This code is provided in Deno repository in the examples directory. So if you have Rust on your system and you clone the repo, you can run this code yourself. So let me do that now. So I'm in my terminal. I'm inside the Deno repository. And now I'm gonna call cargo run -- example hello world. And we will execute the code you just saw on GitHub. So firstly, we see the sum of and printing the contents of the array. And then we get the result back from Rust, which is 6. And obviously this is proper answer because it added all the elements of the array. But then we get an exception, and exception says that certificate errored because it expected an array. And let me quickly go back to the actual code to show you. So indeed, later on, we call opsum again, but this time instead of using an array, we just have a single number. And this is not good because we defined our op in here that we want to use a vector. So if the type you're expecting on the Rust side is not correct, it's a type mismatch, you will get the error automatically. So that ensures that you always uphold your contract between the two sides. Okay, let's jump back into the presentation.
Could we maybe name this way of writing Rust code an equivalent to the C++ add-ons of Node.js?
No, not really. So this is what I just wanted to describe right now is we have something similar to add-ons in Node.js. Those are called plugins in Deno, and indeed they can use those ops. However, this interface right now is in heavy flux, so I wouldn't recommend using it, but those ops are actually what most of the Deno APIs use. So, for example, if you have that will take a path to your file and will read the whole file for you on the Rust side and then send the contents back to JS. And any API that is on the Deno namespace, so say Deno.connect or Deno listen TLS or whatever you can think of, it most likely uses some kind of op underneath. So whenever you need to perform an action that is not pure JavaScript computation, we are reaching from the JavaScript code, from the V8 engine, back to Rust to perform some action and then return you a result. So you can think of ops as a remote procedure call. If you ever used RPC mechanism over internet, this is very similar, but instead it's inside the same process, but across the language boundaries.
Okay.
And in comparison to Node, in Node, when you have some APIs that use native functions, they're most likely bound directly to some JavaScript objects. And in case of Deno, we don't do that. Everything that needs to go from JavaScript to Rust goes through this funnel, which has pretty significant consequences. One of them is that if you improve serialization of this data back and forth, then all of your APIs get this boost for free. But most importantly, you can actually enforce security that way. So the V8 engine is a very good sandbox, but if you start poking holes in the sandbox, it's not so secure anymore. But if you have only a single funnel through which you can send and receive messages, you can enforce a way of permission checks on this funnel level. So just a quick overview. I showed you that we can exchange numbers in here, but we also exchanged a vector or an array in our live code example, but that was not always the case. So this ops system is there from the beginning because that was one of the promises of Deno, the security aspect, and the ops is what allows it to enforce it. But historically, there were many different ways to exchange this data. So firstly, it started probably as proto buffers. Then there was flat buffers, which seemed to be a bit simpler and faster. Then we ripped flat buffers out and just used JSON for encoding. And we even had a custom binary format that could encode exactly 3 integers back and forth for the operations that are like the most performance sensitive. So for example, reading from a net socket or writing to it or reading from a file. So we wanted this to be as efficient as possible. But it turns out that neither of those solutions was perfect or even satisfiable. Performance left a lot to be asked because when you cross the boundary between JavaScript and Rust, you needed to encode and decode this data. So you had to allocate memory in Rust to deserialize your JSON data. And then when you were returning this JSON data back to JS, you had to serialize it and allocate a memory in JavaScript. So I also have an older talk on this subject, but keep in mind, this talk is 2 years old. So there be dragons, but you can also see how much progress has been made on this subsystem in 2 years. So to finish up this section, ideally what we want to do is take a JavaScript object, so a number or an array, as we just did, and turn it into some Rust type directly. And all of the team was like, yeah, no, that's not really possible. Or even if it is, it's not gonna be fast. But well, we love to be proven wrong. And one of the contributors, Aaron Omulan, came to Deno repo a few months ago and said that, yeah, this is doable. And well, it was. He introduced a crate called certv8, which is another serialization layer that allows you to translate JavaScript objects into Rust objects and back very, very efficiently. So no extra allocations, just the minimal amount of work that is required. And it's very fast. On the right-hand side, you can see a chart from our blog post, which is linked in here. We've got about 100x speed up for synchronous ops. So these 3 columns are synchronous ops, and about 10x speed up for asynchronous ops. And again, since all of the actions in Deno go through this funnel of ops, it means that this optimization had impact on all of the Deno APIs. All of them just got faster for free.
That's really amazing.
Okay, so we covered ops. It might be a bit daunting, but now we'll use them and you will see how we can provide reusable parts of the runtime. So enter extensions. Extensions is just a name we came up with. It's nothing more than a Rust crate. So again, Rust crate is something equivalent to NPM package. It's just a bunch of code that is related together. And in this case, this is some JavaScript code alongside some Rust code. So you write some glue code in JavaScript that calls some ops, and then you provide those ops implementation in Rust code. And then you can ship them together. What's really great about it is that we split our APIs granularly. So for example, we have extensions such like Deno Web that provides most of the basic web APIs like event listener, text encoder and decoder, blob, streams, readable stream, writable stream, response, request, like lots of APIs that are very basic to the web. And we also have crates like Deno Console that provides you a standalone implementation of console API with formatting, with inspection of values like proxies or circular objects or whatnot. We have Deno Fetch that provides you with the fetch implementation. This one actually builds on top of Deno Web because in Fetch API, you pass request and get a response object back, and both of them are implemented in the Deno Web crate. Or another example is Deno timers. So set timeout and set interval work in Deno just as well as they do in browsers, and they're implemented as a standalone crate. So if you want, for example, to wait 5 seconds before executing some code, you can just pull this crate and use set timeout. So here's an example of an extension. This is an extension called Deno Crypto. It's a new extension. We just in 1.11 a week ago, we introduced some more web crypto APIs. And let's walk from top to bottom to try and understand and put together all we just talked about. So we just create an extension using provided API, and then we tell the extension, let me get the annotate tool. And then we tell the extension that all of the code in here should be prefixed with extension/crypto. So for example, if an exception is raised because of any of reasons, all of the stack frames from this extension will be prefixed with this phrase. And then we include 2 JavaScript files, one called webidl and the other called crypto. And those numbers here is actually a poor man's way of ordering code for execution. All of the code we're talking about in extensions is plain old JavaScript scripts. So not ES modules, no import, no export, just scripts like you wrote 6 to 10 years ago in the browser. There's so-called IFI that just executes in the global scope. And it turns out this is primitive, but it works very, very well. Okay, so we got some JavaScript code that will be included. And then we got some Rust ops that we've defined. So for example, we got API called crypto.getRandomValues, and lo and behold, it will call exactly this op that is called the same way. And we also got two other ops, one for crypto.saddle.digest API and one for crypto.randomuUID. So in Deno, if you call crypto.getRandomValues, you will not get a number using math.random because it's not a secure PRNG, pseudo random number generator. Instead, we will reach into Rust and then get a random number from Rust API that uses a secure entropy source. And to give you a concrete example, in here we have something called state. State is it's just a container for data that you can pass between ops. So for example, when you create, when you open a file, we might save this file state into this state so it can be used later when you're closing the file. And in this case, we can pass a seed value for our PRNG. So when you use this extension, you might pass an optional unsigned 64-bit integer. And then it might be used as a seed for your pseudo-random number generator. So for example, if you want to run your tests and have deterministic output, you might want to use the same seed over and over again. Okay, let's move on. So this is pretty much it. What comes into, say, building blocks for runtimes based on Deno. You got ops, which allow you to communicate between JavaScript and Rust, and you got extensions, which just group JavaScript and Rust code that provides those ops. So now let's actually see some real world implementation of custom runtimes. So it's not just for the presentation's sake. So we'll start with a simpler one. This runtime is written by my colleague Luca from Denoland. This is a runtime that Luca wrote just for the Web GPU test suite. So Deno added support for Web GPU not so long ago, but the testing story is still pretty dire. So we're collaborating with Web GPU working group to make it better. And what Luca did is provide a slimmed down version of Deno that, so it doesn't work exactly like Deno you download from our releases, but it's also a full-fledged JS runtime. And as can be read in here, there are no Deno APIs available here. So you cannot do Deno.read text file in this case. But instead, you've got all the built-in objects as well as web APIs. For example, yeah, event is a web API, or maybe abort controller and abort signals. These are also web APIs. And you've got a bunch of APIs coming from the actual Web GPU specification. So let me show you the actual code that goes into building such a runtime. Okay, maybe to give a bit more context, why was it done anyway? Building Deno, like if you want to build Deno yourself from scratch, takes a long time, also about 10 to 20, 30 minutes, depending on your machine. So it's quite long for CI if you want to rebuild it on every run. But in this case, we have minimal functionality, just a few extensions that are needed to run the Web GPU suite, and thus this project builds in like a minute or two. So it's not a problem to build it on CI every time. And it's a perfect example where you might want to use a custom runtime instead of using Deno itself, because the goal here is pretty clear. We want to test the web APIs related to web GPU. We don't care about reading files from disk or connecting to a Unix socket or fetching a file from remote servers. So we don't need any of those APIs. We just want web GPU APIs and other APIs that might be needed for the test suite. So let's quickly go through the Rust code to see actual, more concrete implementation of custom runtime. So the run function is our entry point. Think of it like the function that is called first. In here, we just check our CLI arguments and take the first argument, which will be the file name to load. And then we actually create our JS runtime. But this time we're not using default options. So before, in the examples before, I've shown you it was always JS runtime new default, but in here we are actually configuring runtime to do some more concrete stuff. And in this case, we specify a startup snapshot. Snapshot is a special technology from V8 that allows you to serialize the whole JavaScript heap and save it to disk. So then you don't have to execute the same code over and over again on startup. As an example, Deno uses snapshots for TS compiler. TSC is a huge JavaScript file. It's almost 10 megabytes of JavaScript. So if you executed this code on every startup, it will have a few second penalty because that's a lot of code to parse, lex, and execute in V8. But in Deno, when we build the binary, we actually execute this code once and then ask V8 to take a snapshot of this code so we can then reuse it on the startup faster. I also mentioned snapshots in more detail in my previous talk. So if you're interested, just click on the links from the slides. Then we define the module loader. So in this case, we're gonna be loading files from file system. This is a built-in module loader provided by Deno. You just use it. You don't have to think about all the details, how it works under the hood. You give it a file path, it will load stuff for you. Then we got some helper function that allows us to map exceptions to some more concrete types. And then we have extensions, the stuff we just discussed. So let's take a look what extensions are used in this runtime that is used to run web GPU test suite. We got Deno Web IDL, we got Deno Console. So the console API will be available in this context. Then we have Deno Timers. So that means set timeout and set interval will be available. We'll discuss this guy in a second. We've got Deno URL. So the URL implementation will be available as well. We got Deno Web. So all the basic web APIs, text encoder, text decoder, streams, whatnot will be here. And we got web GPU. So all of the APIs that are needed for interacting with your graphics card. And then we got an extension that is just defined in this file. Let me show you real quick to get the idea of how we can construct those extensions. So extension is defined here. It's a function that returns an instance of extension, but in this case, it's super simple. It has only a single op that is called op exit. And if we scroll down a few lines, we can see that op exit only just exits the process. It calls the native Rust API to exit the process. Okay, so we've defined our extensions. We got this strange thing here in case of timers, and I just want to throw back really quick to when I talked about secure by default. So as you might know, Deno requires you to pass -- allow something, flags on CLI. If you want to access internet, you need to pass -- allow net. If you want to read from disk, you use -- allow read. And variables -- allow of end. And in case of timers, there's a specific flag called allow HR time, which stands for allow high resolution time. And this permission is there because high resolution timing might be used for Spectre attacks. So performance.now APIs in JavaScript have a very high resolution, up to nanoseconds, if I'm not mistaken. And those APIs could be used for the Spectre attack. So if you don't pass allow HR time, then we will round this time to 2 milliseconds, and it becomes useless in case of Spectre attacks because the resolution is too low. Okay, so we configured our runtime. We got a bunch of APIs that will be available. Then again, we create the runtime, and then we execute some code. So execute, this is a file name, anon, that's fine. And we just called a function called bootstrap that is available on the global scope. And this gets a bit more complicated because we're actually gonna be executing ES modules. So this thing executes a script. It's super simple, just execute and you're done. But if you want to execute modules, there's a little bit more work involved. You need to first load the module. And as I mentioned previously, this is completely asynchronous because you might fetch the sources from the internet. So we don't want to block the whole process while that's being done. And thus we use the await syntax in Rust. It's a bit different than in JS. It's actually a keyword that you put after the dot. It's not await something like in JS. And then we actually evaluate this ES module. And then once you evaluate this module, you just drive your event loop forward. So you just call run event loop and it will run your code to completion. So for example, if there are timers, then this function will cause those timers to make progress and wake your code after a specified amount of time. So actually, let's take a look at this thing in action. So this is gonna be quite scary and complicated, but hey, we're doing calculations on your graphics card in here. So let's see. First, we obtain an adapter to your GPU, then we get a device, and then we write a shader code. So this is the actual dialect that you can use to perform calculations on your GPU. It could be used for machine learning or similar stuff, maybe for writing efficient games in the browser. Let's not go into detail into this code. It just does some calculation on the GPU. You have to trust me on this one. Then we use some more web APIs to actually obtain the proper structures needed, like we create a buffer, unmap, we create a computational pipeline, whatnot, and let's see the actual results. So let me switch to my terminal once again. Again, this code, you can just download the repo from GitHub and then use cargo run examples hello compute, and let's see what will happen. Right, so we just executed some JavaScript code using our custom built runtime that executes and calculates these values on your GPU, on your graphics card. And literally what it took was, let's see. So we got this Rust file, which is 122 lines of code. And then we got bootstrapping, which is another 180 lines of code, but most of this stuff is not really important, so you could skip some of it. So in 300 lines of code, we just created a custom JavaScript runtime that allows you to run some code on your GPU. It's built using the same technology as Deno itself, but it doesn't have all the same APIs as Deno. It only has APIs that we were interested in this case, some web APIs, some timers, and the web GPU.
Yeah, reaching the web GPU could be hard, I believe, in Node.js, if not impossible nowadays.
I'm not sure, but I think right now Node does not have web GPU support. Maybe it's provided via an add-on or something like this, but I'm not sure. But in Deno, just like in some of the browsers, this is now built in, so you can just use web GPU. Yeah, and let's just take a super quick look at the actual usage of this runtime thing inside Deno binary. So this example is going to be way more complex, but I'll just give you a brief introduction. This is the actual code that if you downloaded Deno runs on your computer. So again, we're defining some extensions that we'll use, but in case of Deno, there's many more of them. So whatever is in Deno will be here. There's web, there's fetch, WebSockets, web storage, broadcast channel. This is a brand new thing, so you can communicate between workers. And here we've got some of the extensions that provide the Deno API. So for example, we got FS. So all the functions that are required to read a file from disk or write it to disk are contained here. We got HTTP, which provides you with a high performance HTTP server that you call from JavaScript in 3 lines of code. And it's all concisely encapsulated in this extensions abstraction that allows you to just include whatever you need in this concrete example. Yeah, okay. That's probably enough of the technicalities for now. Yeah, so let me wrap up my talk by saying that if you've ever been interested in contributing to open source project, come to Deno. We welcome all contributions. We've got over 600 contributors already. There are numerous repos that you might contribute to depending on what interests you or your skill level. You can contribute to the main runtime if you know Rust and some low-level JavaScript. You can contribute to the standard library if you know TypeScript and are interested only in TypeScript and JavaScript APIs. Or maybe you'd like to contribute to a linter or documentation generator, both written in Rust, but way simpler than the actual runtime. Or maybe you are good in front end and would like to help us with our documentation generator website, which is available for everyone. And you can view documentation for literally any ES module available on the internet. So we actually parse out the JS docs that you write inside your code and then present you with a nice front end for all of the public API in the module. Yeah, that's it from me. Thank you again for having me. This is the question time. I will take as many as there are and try to answer all of them.
Yeah, thank you very much, Bartek. It was really an awesome talk, and to give us the full overview of Deno in just around 1 hour. So really, guys, don't hesitate to write a question right now in the comments. I know we have some delay, possibly between Zoom and YouTube and Facebook. So just please write it down. I see just some comments that people love Rust and love TypeScript. So it's definitely better than C++. Yes, it's very hard. Okay, so maybe I will right now go to some questions, but really, please, guys, don't hesitate to write anything here. And what interests me, it's also outside of maybe just pure development perspective, maybe going more into, I don't know, business things, because let's imagine that we have somebody that would like to have some JavaScript on the backend, and obviously right now it's just Node.js, and Deno is because it's stable from some time. So are there reasons to switch from Node.js to Deno, and how you can convince somebody, or what could be the reasons to try out Deno and where it should be better than Node when you think about some real life business projects?
Right. So this is actually a very complex question that has several answers. Let me try to start with where you might want to use Deno today. Deno is a great replacement for any scripts that historically may be written in Bash or Python or Ruby. And the reason is that Deno is a single file. If you want to use Deno, you just download a single executable file, and that's it, what you need to run. So it's very portable. It's not like Python that you need to install it with a number of other files and then set up your side packages and whatnot. In Deno, you just get a single binary. But even better, if your tools are required to be shared with others, you can use Deno compile, which I described in the beginning. Let me scroll back a bit. Yeah, so we got this Deno compile subcommand that allows you to compile your JavaScript code alongside the whole Deno binary in a single file. So for example, if you write a deployment script, you might then do Deno compile path to my script, and you will get a single executable file. I must note that it might be a bit heavy, but it's a single file that you can then send to everyone, and even you can cross-compile it to different architectures. So if you're using Mac, you might do you might compile a version for Linux or Windows. So that's one of the use cases. The other use case that Deno is really great for is, well, writing edge handler. So Deno deploy, this will be a bit of shameless plug. So we are working on this platform called Deno deploy, and to write your handlers for deploy, you just use Deno CLI with a little script that sets up proper types and permissions. We're working hard towards bringing better web development experience to Deno. We're also working hard to bringing more of Node compatibility. We have a special package inside our standard library that provides you a compatibility layer. It's not done, but it's getting better every month. So really, what Deno is great for very much depends on why are you not happy with Node, or you started hating Python for deployment scripts because it's hard to keep it in sync across servers. Yeah, as I said, Deno is a single file. You get this file and you're done. You can use all of the Deno functionality from this single file, and it will always be a single file distributed. Could you repeat the other part of your question, because it already slipped my mind?
Okay, maybe too long. Yeah, don't blame Python that much. I have a lot of Python enthusiasts here in my company, and I know that you are also a former Python developer, right?
Yes, I was, but I converted to Deno.
Directly. Okay, so that's yeah. I mean, that sounds really nice, because the deployment on Deno deploy may be as easy as on Heroku, right, or even easier.
Yeah, it should be easier. It's literally a single click where you link to your either GitHub project or just upload a snippet of script, and it gets deployed all over the world. So if you want to manipulate headers or do server-side generation, it's all possible using deploy.
It's definitely worth a try for the cloud deployments. So I saw some attempts to use Deno. Of course, we can use it in the container on Kubernetes. Yeah, just Dockerize it. We can also, I see some attempts in projects how to run it on Lambda, because it's
it's possible.
It's also possible. But I know one of the main goals that were that much interesting for me in the early days of Node.js, let's say, I don't know, 6 or 10 years ago, it was about running Node.js code on embedded devices. Yeah. And I know that it was maybe more popular at the beginning, but then Node.js just goes straight to cloud. And I don't know, are inside this, Deno working group and this core team, do you also think that it could be a nice runtime also for embedded devices, not write code in C++ there?
it all boils down to the fact if you can run V8 on given embedded device. There are works being done to make it possible to run Deno on Raspberry Pi and some of the mobile systems, Android and maybe iOS. But given how constrained are most of the embedded devices, I wouldn't say that that's going to be easily possible because of the V8 engine. V8 can be compiled to a lot of different architectures, but it won't be easy. And to be honest, right up to this point, we did not really put much attention into embedded devices because there was not so much interest from the community, much more interest for running Deno on Raspberry Pi or even on Android.
Oh, okay. Yeah, that's true. On embedded,
going back to the comparisons, so there's a lot of things that Deno can definitely do better. It's a fresh new project. I wonder how ready it is to support long-running software projects. So what I mean specifically is one thing I don't know how Deno does it is diagnostics. So what kind of diagnostics capabilities do we have? Like I'm assuming if it's V8, there's going to be a heap snapshot and a profiler. Can you do flame graphs for Deno?
Correct. So yes, you can do flame graphs. Actually, most of our performance improvements are done using flame graphs. In my case, I just used a tool called Cargo Flame Graph, which integrates into the Rust build chain. And if you did cargo run to build and run your project, you can as well do cargo flame graph, and it will create a flame graph for you. And as for the V8 inspector, yep, we just integrate with V8 inspector. Some of the functionality like heap snapshot might not work at the moment, but it's either because there are missing bindings and no one asked for them yet, or just something it hasn't been yet implemented. But there are really no blockers for like full support in Chrome DevTools, and flame graphing is certainly possible. You can obviously also detrust Deno or just use LLDB if you want to go very low level, and you can debug it whatever way you like.
Okay, and do you get your JavaScript reference names in there?
Yes, I believe you do. Yes, I haven't used LLDB in Deno for about a year now, but last time I checked, yeah, you could see JS references in there.
Okay, what about TypeScript? Because that's something I was never able to do with Node. If you transpile, you're then diagnosing the result of transpilation of your code. So there's no references to your own function names unless they transpile to exactly the same, right?
Okay, so in case of transpilation, Deno doesn't really use TypeScript compiler to do that because it was too slow. So we switched to something called SWC, which stands for Speedy Web Compiler. It's a transpiler written in Rust, and it's actually a backbone for most of our infrastructure that analyzes your code and transpiles it. And all of the results are placed inside a single directory, which is controlled by Deno environmental variable. So it's easily inspectable by you. And the code that is transpiled should be as close to the original code as possible. That is, strip out the types, but if it's possible, don't rename anything and don't mangle the names. Just strip out the types and make your TypeScript into a JavaScript. Plus, you can also get
sorry.
Yeah, you can also get debug logs out of TypeScript compiler during the type checking, as well as the language server that we provide. There's also a bunch of debug logs in there.
Okay, so that sounds very promising for the heap snapshot case as well. You should probably get the right references in the heap snapshot too, out of the box from V8. And anything like async hooks, for
so async hooks
APM
are currently
providers?
not supported. There is a PR that from one of the Node contributors that wanted to add it to Deno, but it kind of died down. So it's like in the purgatory for now. But it seems it's one of the most requested features from Node folks. So I think it's gonna land in Deno sooner than later. There's also promise hooks that are exposed by V8 directly. So it's not like a proprietary API or invented API, but it's like the same API that all embedders of V8 use. So we might want to go with promise hooks instead of async hooks.
Okay, sounds good.
Yeah, really, that sounds like a really good project for future production use. I saw also some common questions from the people. Whenever the meeting will be recorded, yes, as always, we do this stuff with DataArt. You already can watch it, the whole recording after the end of the meeting. Do you have slides share? Of course, Bartek share the slides with us. And one question about Google API. Another hand is asking, is it not whenever or when there will be a library to communicate with Google API? I saw there is the name is reserved already for Google API, yeah? So is it a matter like you encourage some people to write those kinds of libraries?
Well,
community
to be honest, this is up to the community. We don't really write the bindings for AWS or Google ourselves. We encourage the community to do so. We try to collaborate with community on projects like this. For example, there's a great organization on GitHub called DenoDB, which actually unifies all of the DB drivers under a single organization. So contributors can collaborate and try to make the interfaces as similar as possible. But to answer the question directly, no, we do not plan to add Google API. We encourage the community to do so. Also, I encourage you to go to our Discord. So discord.gg/Deno and ask there. Maybe someone already wrote such a library, but it may have some different name.
Yeah, this Discord server is really awesome. As I saw it, there's a lot of work in progress. Yeah, the DenoDB project seems to be quite promising. There were also some questions about the Prisma, because we also have one folk from Prisma and also Node.js Wrocław 8. So it's possibly just more to come. So just if you're asking this question, just contribute, yeah, to the source.
Yeah, I remember there were a few questions about Prisma recently. So again, I suggest to go to Discord. I just can't keep track of all the packages that are going on in the community. But yeah, as Cezary said, our Discord is awesome. You will get help there almost immediately. So if you have any questions like that, I suggest to go to the Discord, Deno Discord. So discord.gg/Deno.
Yes, exactly. That's the best way to communicate both Bartek and also another core contributors, just contributors here. Whenever you bring something valuable and would like to show it, I believe you will get the answer. So yeah. I think this is mostly of the questions. So you have really an awesome material. It is something that I will possibly do myself. Look once again, also share it with the others, because it's really like up-to-date state of the Deno. I hope it will be still up-to-date this year, possibly next year.
Yeah, it should
talk. So sorry, great thanks for you, Bartek, for the Deno. I hope to also have more talks about Deno on our meetups. And right now the experimental part. I hope we can introduce with the sound, with the music. One of my friends is going to play. So everybody who's connected here with Zoom could stay. Also, if we have still some people on YouTube, please write if you're still there, and we'll try to connect the music. Let me know when something goes wrong. We'll see how it happens. Okay, there is going to be a surprise. here. Just I will connect the different camera and unmute. Are we there? Could we start, Marta?
Yes, we can.
Okay, so let's focus the screen on Frederick and let's go.
Okay, hello. Hello, I'm Francis Tuan. Nice to be here. Thanks for an invitation. My friend Czarek asked me to play this song first, so I will start with this. Thank you very much. We have a little audience here, and welcome everyone in our streaming concert. As I said, I'm Francis Twan. I have a couple of my songs from newest album. This album is called Let's Pretend, and it's the same title as the next song. I will play title song, Let's Pretend. Let's pretend the opposite is happening. Let's pretend it now. Let's pretend the opposite is happening. Let's pretend it now. Let's pretend the opposite is happening. Let's pretend it please. Let's pretend the opposite is happening. Let's pretend it please. Let's pretend the opposite is happening. Let's pretend it now. Let's pretend the opposite is happening. Let's pretend it now. Let's pretend the opposite is happening. Let's pretend it please. Let's pretend the opposite is happening. Let's pretend it please. Do-da, do-da, do, do-da, do. Do-da, do-da, do, do-da, do. Thank you very much. And now I want to introduce you one strange instrument. And this instrument is called Denoland, and it is original ethno instrument from Vietnam. My father is from Vietnam, so I know some musical stuff from this very oriental place in this world, and I want to play a song with it. This song has, I think, beautiful message. It's about water. I think that you should drink water and do everything that water can bring into our lives. For example, you can come to the water and just jump into it and feel good with it, and it's all about not being scared about water. Water is your friend. And this song is called "Come to the Water." It's so easy to feel grateful, standing there on solid ground. No one's hurting, no one's beautiful. No one thinks of giving up. But sometimes life's a little crazy, running out of hope we're lost. No one promised us we're sailing, yet they make us dance in storms. Come to the water, baby, help us find your peace. Come to the water and believe. There's living water in the world, you never runs dry. Come to the water that satisfies. How does one breathe underwater? Would you rather walk on shore, knowing there's more to discover? It's surrendered to the undertow. Come to the water, baby, help us find your peace. Come to the water and believe. There's living water in the world here, never runs dry. Come to the water that satisfies. Come to the water now. Come to the water now. Come to the water now. Come to the water. Come to the water now. Come to the water. Come to the water now. Come to the water. Come to the water now. Come to the water. Come to the water now. Come to the water, baby. Help us find your peace. Come to the water and believe. There's living water in the brook, you never runs dry. Come to the water that satisfies. Come to the water now. Come to the water now. Thank you very much. I hope that you're not bored sitting in the front of the screen whole 2 years, I guess. I experienced this boring thing that you still watch the screen and talk to people. You should talk to them in real life, but you have them on the screen like you're watching film, and sometimes films are boring too, and that is what all of this is. Song, next song is all about these things, all this stuff that we experience when we are sitting in the front of the screen, getting bored and still not satisfied about our daily life. This song is called "I Was Bored." I was bored of everything that I had even done. I gave up all the time before. I finally tried to love. I am the big bored of loving now. I still watch the same old music videos from the modular stars. I find nothing that beats their mystical style. I will not change this until I die. I could have died alive again today, and this is the sun's birthday, this is birthday of life, of love and wings, and of the gang, great happening in the neighborhood. I think you got the most, this amazing day for the leaping, bringing the spirits of trees and their future dream of sky, and for everything which is natural, which is infinite, which is yes, which is yes. How should tasting, touching, hearing, sing? Breathing and lift from the now. Couple nights feeling down, I'll imagine love you. Ways the way it can. Nothing else but my eyes are open. Nothing is my ears the way it can. Nothing else but my eyes are open. Nothing is my ears the way it can. Nothing else but my eyes are open. Nothing is my ears the way. Thank you very much. Thank you for the invitation. I played a couple of songs from my last two albums. No, I released only two. So from all of my discography, you can find it in your favorite streaming sites, favorite streaming applications like YouTube, Spotify. If you want, you can check them and maybe find something interesting. Sometimes I play also with whole band. Today we have this very quiet gig, but we also play some more rock and roll things. And the last thing is not rock and roll; it's rather a song that is that contains a lot of emotions and it's very slow, but it's about going through the desert. You can mean desert all you want. It's up to you because it's poem. It's my adaptation of Robert Frost poem Desert Places, and it's the last song today. I hope you will have a great evening and maybe see you in real life in the future. There's a place Thank you very much, and see you next time. Thank you very much for attention.
That's the question what to do at the end, because we need to improvise a little bit, because we don't agree on how to end this meeting, actually. So what I would say, those songs tell a story, and I would say like the first song, the first two words. I also connect somehow what Bartek says before, because it's, you know, this innovation of technology when somebody's moving, starting something new.
Yes, that's how universe works. You know, something move, and you know, there's another movement and another and another, and still you push something and you don't know what to expect next.
But somebody needs to start that.
Yes.
So really, it's really great to have world-class speaker and a world-class artist here. I believe it's just the beginning of this series.
Okay.
We have another event right now. Maybe I will try to connect to Marta. Maybe you're always making the best for closing.
Yes, I'm here.
Shipping to everyone.
Yes, I'm here. Thank you very much once again. Thank you to our lovely speaker, Bartek, and to you, Cezary, for moderating and for organizing this amazing surprise for us. And I hope, guys, that we will see each other soon, maybe even offline. Let's see how it will go. So great. Thank you very much, and see you on our next Node.js meetup.